CSE, NERIST since 2006. He is pursuing doctoral studies in neuroimaging and multimodal algorithms at IIT Guwahati. His research interests include machine learning, evolutionary algorithms, medical imaging, and computational biology. Thank you, sir, for joining us. The floor is yours, sir. Sir, unmute yourself, sir.
Yeah. Thank you, Alok. Thank you so much for giving the opportunity to interact the students. And I'm very sorry because I got my lunch late and followed by some excitement stories at my end. So I got late. So I may stretch up to 3:40. I'll get 10, 15 minutes more, or it's not possible, no?
Yes, sir. Yes, sir.
Yeah. So today's discussion is Alok sir has informed me that the participants will be the beginners. So I mentally prepared that we'll talk about machine learning and how we can implement in Python. Okay. So what is there in this course is we'll understand what is machine learning, what is the terminologies involved, and how we can implement in Python. But what it doesn't include is the algorithms. Okay, so whatever the methods or algorithms we'll study now, we'll treat them as a black box, and we'll just understand what they are doing. Okay, because within 1.5 an hour we cannot discuss much. But the main objective is we'll discuss in such a way that just after the class you can implement by yourself. So whatever the machine learning ideas you have, you can implement, and that's what the main objective behind the design of this course. I mean, design of this lecture. So let me share the screen, and I'll put my video off if you find it uneasy, because sometimes the speaker must come in video. It makes sense, and sometimes it is very much I mean, it really enhances the attention power of the audience. But because of the network issue, I'll be going off in between sometimes. So let me share the screen. Could you see the screen? Someone has to say yes.
Yes, sir.
Yes. Whether my volume is audible, Alok, clear? Is it
Audible.
clear? Audible, na? And volume is also perfect?
Yes, sir.
Yes. So we'll be talking about machine learning, and people might get confused when they also come across something called deep learning and artificial intelligence. Okay. As in many courses and many applications, people use these three words synonymously. That means whenever they refer machine learning or deep learning or artificial intelligence, they mean it by the same name, same concept. So the idea is actually the artificial intelligence is a superset. So it includes all ideas that we discuss in machine learning, and the artificial includes intelligence includes all the ideas that we discuss in deep learning as well. Okay. So what is machine learning? It is I mean, machine learning is a set of algorithms. Each algorithm has some objective. So that algorithm learn from the data and make decisions. Okay. And these decisions are made based on the patterns in the data or based on the statistical properties in the data. Okay. And sometimes there are so much hidden information in some data that a human being cannot see with the simple statistical methods. So there are models. Okay. So those models are also known as algorithms, or we can say machine learning procedures also. So those algorithms really read the data, and by the application of mathematical principles or statistical principles, they identify or they determine the patterns in the data, and finally they come to a conclusion. Okay, so we'll talk about what is their conclusion, and uh, you know the examples and the reasons behind the decisions and so on. But before that, I would like to go back to to the audience, just to ask a question, that how many of you have ever read or ever studied machine learning? Raise your hand, please. It's just a wake up call, because just after the lunch, some of you might be feeling sleepy. So this is one of my methods to make you wake up. At the same point of time, I need some information about uh, whether you are aware of machine learning earlier or not. Please raise your hand. How many hands raised? I could not see none. So how many of you are listening really seriously? Am I audible? I would repeat that there is a question from my side, that how many of you have ever read machine learning or ever studied machine learning? Raise your hand, please. Okay. Instead of raising the hands, if you are leaving the meeting actually. Okay. Actually, someone has to respond from the audience side. How could I know that you are listening? Any of you can say yes. Unmute yourself and say yes. हेलो हेलो, am I audible?
Yes, sir.
कोई
Yes,
सुन
yes.
रहे हैं क्या? कोई रेज भी नहीं कर रहे हैंड, एंड none of them responding.
Sir, अभी दे रहे हैं सर.
Yes, sir. Listen, sir.
Listening na? Okay, okay.
Yes, sir, listening.
Okay, very good, very good. Okay,
Yes, sir.
very good. So artificial intelligence means a superset of all the algorithms. The broad idea behind artificial intelligence, that can we write algorithms? Can we design systems which can behave just like a human? That's mean that we simulate the human intelligence, and a system can do what a human being could. Okay, can do something that a human being could do. And deep learning is something where we have something called deep, the terminology deep. Okay. So the deep word indicates that there are a huge number of layers of information being utilized. Okay. That's where the deep. So generally we use a network with so many layers. Okay. And the number of layers are more than usual. That's why the terminology deep learning. And the reason behind using so many, I mean, the so many layers, is that we are getting some more information from the hidden pattern in the data. Okay. Now, our focus is on the machine learning, so not touch upon deep learning and AI in a broad sense, but we'll be pinpointing what is machine learning all about. So here is the three types of learning we can have. Okay, so we write one method. Okay, we call it a method or algorithm or procedure. Okay, and this algorithm or procedure can employ any of this method to do the job. Okay, so what is happening, that if we have a data set, okay, we have a data set. So what is a data set? It could be any information about natural phenomena. So we can say that the data set for the environment or the temperature data set, we can say, okay, or we can say environment data set, if these are the wind information, wind speed. Okay, this is information about wind. This is information about humidity. This is information about temperature maybe. Okay, so given these three information, we can decide the status of the day, maybe sunny, maybe cloudy, maybe partially cloudy, maybe rainy, and so on. Okay, so this is called label. Okay, so now you are aware of what does one column mean and what does this label mean. Now what are the row? The rows are the information about every day. Okay, so every day I have information about wind, information about humidity, information about temperature, and the status of the day is sunny. We have experimented and we decided this. Now we have, let's say, information about this data set, information about 1 year maybe. Okay, so this is the data of 1 year, 365 days. Now, given this data, I will give it this to my machine learning algorithm. Okay, and the machine learning learns it. The machine learning algorithm reads every line. Okay, and it makes some kind of inference, some kind of knowledge gain. Okay, and now the machine learning is said to be learned or gained the knowledge about the data we have given as input. So question is, what is the purpose behind doing this learning? The purpose is now I can predict the status of 366 day. Okay, so you can guess what could be the day, maybe cloudy. Okay. So the idea is this is information about 365 days. So having knowing 365 days characteristics, I can guess the 36th day status. That's the job of machine learning. One of classical example. And now why I have given this example, just to distinguish between what is supervised learning, what is unsupervised learning, what is reinforcement learning. Okay, and their brief idea is also given. Supervised learning is task driven. It predicts the next value, as I told you. Having knowing 365 days information, it predicts what should be my 360 day, what will be the status of the day on 367th, what is the day on 368, and so on. Any day thing you can guess, predict. That's called supervised learning. And in unsupervised learning, we have to have the same data set, but the labels are not given. Okay, so the status of sunny, cloudy, partially cloudy, and rainy, it's not given, then that is called unsupervised learning. Okay, and reinforcement learning is something different, where we have an environment. Okay, and in that environment there is something called one agent. Okay, so it's all program. This agent explores the environment to solve a problem. Okay, so while solving the problem, it travels through this path and it reaches here at this point. Okay, and if it is the right point to be reached, then it gets reward. And if it goes this way and reaches this point in the environment, if this is not the right point, we have predefined information, so it will get punishment. So the idea is, in order to explore the solution, the agent learns from its mistakes or rewards from its correct happenings or correct actions. Okay, so this is kind of machine learning, and it is typically totally different from this first two. Okay, now we'll in detail talk about these things, and we'll also implement it in program. But at this moment, I would like to go back to the audience just to know that whether they have some questions or not. If they do not have any questions, we will proceed. I'll not take much time. Just 5 seconds will be given In 5 seconds, you ask a question.
Audience, you can ask any question.
Alok, hopefully I'm clear I'm audible, loud and clear.
Yes, sir. Loud and clear.
Yes, sir. You are clear, sir.
Yes, Manish, thank you. Thank you. Let me go back to the screen where we are discussing. Okay. So it's a nice discussion. I always promote the participants to be interactive. You should not hesitate, ask questions. Okay. And we'll take time. We are not in a hurry. So ask questions if, if you have any. And if you're feeling sleepy, please wash your face and come back and join. Now we'll talk about two things, and in Python we'll talk. In Python we'll talk about machine learning algorithms to implement classification and clustering. So these are the two basic, problems in machine learning. Okay. So the classification is supervised learning. The clustering is unsupervised learning. As I told you that in a data set, we have so many attributes or features we can say, and labels. Then we give this data to the model, and the model is said to be learned in supervised way. If there is no such label given, okay, if there is no such level given, then it will be unsupervised. Okay, and we'll talk about this. So this is clustering. And the difference is given. We'll come back to know the difference later on. Okay, now let me go to the Python. And before going to the Python, I'll be here to brief about Python. So Python is a very popular language, which is open source. You need not purchase it. The compiler is free. The packages are free. So what is a package? So the package is something called inbuilt functionality. So this package provides some inbuilt functionalities. Okay. So you need not write something from scratch. Okay. For example, if you are asked to find a sorting of 10 numbers, okay, 10 numbers given to you, and if you are asked to sort the numbers, what do? You have to write such an algorithm. So many codes you have to write, programming statements to find sorting of 10 numbers, to sort 10 numbers. But if package is there, then you can use an inbuilt functionality like sort, give these 10 numbers as input, and you will get the output. So in one sentence, okay, in one sentence, you will get the output. That's what the package helps you. Get the point? I think the laymen can understand the package is such powerful that somebody has written the code for you. You have to use just a single line called a function to make use of the definition of this function. The function is defined in this package. Somebody has written this much code for you, so you need not write this much code. That's what the beauty of Python. Okay, so we are going to use the scikit-learn package. For machine learning. Okay, and for deep learning, people are use Keras, Theano, and so on. Okay, so our main job is to learn scikit-learn. So at the outset, I mentioned I'm very much objective in this class because of a very limited time period we have been given, that we are now going to learn classification and clustering procedures using Python. Okay. So at this point of time, let me go to the compiler where we'll do this job. Okay. So I'll tell you that the Python can be used in Python Colab, Python compiler in Google. We can call it Google Colab, or you can use something called Spider compiler in a platform Anaconda. To note down these points. The third option is that you can use the standalone Spider IDE, interactive development environment. So these are the three options you have to run your code in Python. There are many options, but I prefer any of these three. These three are effective. There is something called PyCharm, which I do not like personally because it has so many bugs, it gets hang sometimes. These three I have used in the past, so I would suggest you that these three are very smooth. Now I'll go to Colab to show you the codes in Python. Okay. Before that, I will go back to the previous page to say something. So whenever there is a package called scikit-learn, there are so many sub packages also, and each sub package is one algorithm of machine learning. Okay, so we will call them with the keyword called import. Okay, in the syntax of the language, the import is a keyword so that we can include the package in your program. Okay, so let me go to the screen. I will take a few seconds to start my Colab. Okay, so I hope you could see the platform now. It's the Colab. Okay, and here we'll write small Python programs to learn machine learning. Okay, let's enjoy one by one the programs. Okay, so at the very beginning, I will show you the first sentence. The first sentence goes like this: from sklearn import packages, import metrics. Okay, so as I show you in the package, the package tree, sklearn is at the root of the tree. There are many sub packages. So one such sub package is metrics I want to import. That means I have to include that in my main program. Okay, that's what the beauty of Python. There are so much inbuilt functionalities there. Now, what I do is I want to have three class labels. I want to check the classes cat, fish, and hen. Okay. I want to distinguish cat, fish, and hen. Then I declare two lists or two arrays. One array I gave the name expected. The other array name I want to give predicted. So the idea is my model is hidden. I'm just telling you something where I can distinguish the classes. Suppose in between there is a model, okay? I just hidden the model. The idea is I'm expecting these classes and my model is predicting these classes. So I want to check what is the efficiency of my model. That's what the first program we are talking about. Got a point? So before that, I need to tell you something, it seems. Okay, but let's discuss this. Now I typed one more sentence. Matrix is the keyword, as I told you. So matrix.confusion matrix is another keyword. Then I want to give the parameters expected and y prediction the array. It will print the confusion matrix. What that confusion matrix is all about, we'll also study. Okay. Then I would like to mention classification report as well. As we are doing the classification, there are 3 classes. And I want to print something very specific just to convince you that the accuracy of the model could be like this. And let's print the accuracy. This is my simple program. Could you follow me, all of you? Some of you have to say yes. If no, I would again explain. Yes?
Yes, sir.
Okay. Let me run it. I hope you could follow. How could I run? I just click on this button. So I got some result, The result is like this. So the classification accuracy is 0.48. Okay. So where this I got, this is the confusion matrix. Okay. So this confusion matrix has 3 rows, 3 columns. It's a square matrix, indicating that I have 3 classes. Okay. So the accuracy is 0.48. Why? Why so? Could you guess? And there are other terminologies also: precision, recall, F1 score, support, and all. Support means we have 25 numbers: 6 number of cat, 10 number of fishes, 9 number of hen. See, or I'm telling the something different: 6 number of cat, 10 number of fish, and 9 number of hen. And these are my predictions. So the idea is, if I'm expecting my model to guess C and I'm guessing Y, so it's correct answer. And if I'm guessing C, I'm expecting C and my model can guess Y, it's a correct answer. So the idea is that confusion matrix is constructed that way, and the accuracy says that 4 plus 2 plus 6, how much? 12. 12 by total instances is 25, is 0.48. Okay. That's what the thing. You look at this code. In the meantime, I'd just take a 10-second break to have some water. I'm back. I hope some of you have confusion. Let me put forward another example, then we get to know about both the programs. Let me start with another code. And in this code, I'll take a classifier model. Okay. So try to understand. I'm presenting you two programs in the beginning. One is just simply the classes. I'm not using the model. In the second program, I'm using the model. And what the model is guessing, we'll talk about. So, as usual, the first sentence of my program one also I'm using metrics so that I can evaluate my model. What do you mean by metrics? Metrics is a measurement, okay, to assess how effectively my model is working. Now let me use a model from the package, from the inbuilt functionalities, as I told you earlier. And for that, I would like to write another sentence in my program like this. So MLP classifier is an algorithm. We are not talking about the algorithm, as I told you in the beginning. The scope of this discussion is only talking about the program and the ideas behind the machine learning. So we have this sentence. Now, I will define my data set. This is my input data set. As initial I told you, we have to give the data set as input to the model, and the model here is MLP classifier. Now I'm giving the target. Targets are the labels. That means if the input is 0, 0, the output is 0. This is my second input. If the input is 0, 1, my output is 1. If the input is 1, 0, my output is 1. If the input is 1, 1, my output is 0. Okay. So these two lines, my data and target, are my labeled data. As you know, we need labeled data for classification. Okay. Then I train my model. There are many terminologies coming into picture. I will explain. I train my model. So how I train? I call my algorithm MLP classifier, and I give the required parameters, the number of iterations 150. Then fit is another function in association with the MLP classifier, and it needs my data as input. My data is the attributes, target is the label. Okay, you remember? Sometimes before I talked about attributes or features and the target of every row in my data set. So in this data set, we can say we have 4 rows, 2 columns. 2 columns represent 2 attributes. 4 columns represents 4 rows. 4 rows represents 4 data points. And for each row, I have a label 0, 1, 1, and 0. Now, I can test my model. You know this, as I told you, that we have to train the model. That means my model is going through the data and making some inferences. Then finally, we are carrying out a testing procedure. So predict is a keyword, and this predict is used in association with the model I have created, my model. See, my model dot predict. Predict is an inbuilt function. Fit is an inbuilt function. Okay, so these functions have been defined in sklearn.neural network, I mean sklearn package. Okay, and also I can print the performance of the model, that is known as confusion matrix. Also, I can calculate the accuracy. Okay, and we can print the accuracy as well. Okay, the program has been written. The required packages I have included. I'm repeating. We have included the required packages. Then we define our data set. Then we train our model. Next step is testing our model. After testing, I am printing the metrics, or I'm evaluating how effectively my model is working. Okay, so these are the steps. Now run the program. And we got the result. There is some warning message. Let's ignore. It's saying that some convergence warning, maximum iterations reached, and the optimization has not converged yet. That means it says that the 150 iterations is very, very minimal, the indication. So we can increase it to 250. Let's rerun. Still, it gives something like that. Let's ignore for the time being. Whenever we'll do some research, we'll do that. But for the time being, we have to understand there is no error. Okay. So remember, whenever there is warning, there is something undesirable stuff going on, but there is no error. So if there is no error, we have no worry. Let's interpret the result. This is the confusion matrix, and the accuracy is 100%. What do you mean by accuracy is 100%? That means my target is 0, 1, 1, 0. I train my model with this data, with this level, and I also test my model with this data and with this target. You see, I'll show you where I asked the, this is where I tested. Target is this matrix, and prediction is this matrix. Two metrics, matrix means it's a row, okay, row matrix. So not be confused. MATRIX matrix means an array, a list of objects. METRICS matrix means the parameters to evaluate the model. Okay, you should not be confused what is matrix and what is matrix. MATRIX matrix, everyone knows that. So I have a two-dimensional matrix called confusion matrix. Okay, so the idea is 2 and 2 gives me 4. So I have no wrongly guessed stuff. That's why these elements are 0, 0. And we got the result. Okay. So I hope you may have some confusion. That confusion I will clarify in another slide. But can you ask any confusion? Did you understand the two questions? Again, I repeat in 10 seconds, what is the objective behind discussing the first program? In first program, I'm not concerned about the model. What I'm doing is that I expect these labels during my testing period procedure, and my model predicts this. So what is the efficiency of the model? That's I did. So the main purpose is to learn the syntax here. In the second program, we are implementing a model MLP classifier. We are giving a toy data, and we're getting the result like this. Any doubts? I think if you are getting bored, I have to come online. As I promised that I have to come online in video. Any of you have some questions, please raise. No questions. I'm surprised that how could you ask no questions? If it would have been a offline class, what I encourage is you have to ask questions. Otherwise, I have to ask questions. Any discussion must not go questionless. Okay, the moment I ask questions, people want to leave. So it's not a good practice. Okay, let me go back to the screen. So, what is confusion matrix? I will tell you. So, the name itself is confusion. Okay. We'll talk about confusion matrix. And we'll talk about these word metrics as well. Okay, there are varied metrics. One of the metrics is called accuracy. Okay, so in a confusion matrix, what is happening that we have a data set 0, 0, x and y, two inputs, and the output, or which is called level, okay, is 0. If it is 0, 1, the level is 1, for example. If it is 1, 0, the level is 1. If it is 1, 1, the level is 0. That's what our input data. Okay, to the model MLP classifier. Okay, so the model trains this. Trains with the data. And after training, in the testing phase, it uses two things. One, expected result and predicted result. The model can predict. So what is the expected result? After training this, I'm again asking the model, hey model, if I give you 0, 0, can you guess the result is 0? Okay. Then in testing phase, I'm asking the model, hey model, if I give you the input 0, 1, can you guess what is the label? If I give you the data 1, 0, can you guess this label? If give you this data, can you guess this label? That's what I'm doing in the testing phase. Okay. So in testing phase, I'm expecting 0, 1, 1, 0. What is my true label? Okay. And my model predicts something like 1, 0, 1, and 0. Okay. So I create a confusion matrix out of this data and this data. Okay. My pen is malfunctioning. I do not know why. What is the problem? Array. Let me restart it now. Alright, something's happening. Let me change the pen. Okay. So if I'm expecting 0, sorry for the inconvenience, my pen is malfunctioning. I do not know the softwares. So I'm expecting 0. Array. Pen color also could not be changed. Okay, I'm expecting 0. I'm expecting 1, suppose, and these are my predicted values 0 and 1. So whenever I'm expecting 0, I'm getting 1. That means I'm expecting 0, I'm getting 1. It becomes 1. Initially, they all are 0, the count. So whenever I'm expecting 0, I'm getting 1, it becomes 1. Whenever I'm expecting 1, getting 0, expecting 1, getting 0, it becomes 1. Expecting 1, getting 1, 1, 1, it getting 1. And I'm expecting 0, getting 0. Where is that? Here it is. So in 4 occasions, I'm getting 4. And for your information, my pen is now working fine. So the idea is that these are undesirable because I'm expecting 1, getting 0. It's wrong. And this is undesirable because I'm expecting 0, getting 1, which is wrong. So the whole idea is that these are my desired answers. I'm expecting 0, getting 0. I am expecting 1, getting 1. So my accuracy is 1 plus 1, 2 divided by 4 is 0.5, 50%. So this is how we understand the confusion matrix. And I'm very sorry, I don't know why my pen tablet is continuously typing. When I move, it goes also with me. And there may be some issue in the pen. Okay. Any doubts?
No, sir.
No. Okay. Now, such a confusion matrix is there. I told you that only one matrix I talked about here. Okay. There are other metrics I'll show you. These are the other matrices: precision, recall, F1, accuracy, and specificity. So true positive means this one. Predicted values are 1, actual value is 1. So this matrix is totally twisted. I mean, bit twisted because initially I was taking this part as actual, this part as predicted, but no issue. You can take this part as predicted, this is actual. So the girl is expected to be pregnant, and the nurse says that, okay, you are pregnant, that is true positive. If the doctor says a man that you are pregnant, then he is bluffing. So it's false positive. The man cannot be pregnant. And here, something here, I mean, she is pregnant, but the doctor says, no, you're not pregnant. This is undesirable, jute. So this is called false negative. And this is true negative. I mean, he's not pregnant, and he's been told that you're not pregnant. Okay, so this is how we distinguish between true positive, false negative, and true negative. In many research papers, we'll also come across these terminologies. We most of the time getting confused about this true positive, false negative, and true negative. And this is one of the examples which I like. And this is such an interesting example that nobody can forget this the idea about these confusing terms. And because of these confusing terms, the matrix itself known as confusion matrix. And these are the things we use to evaluate the performance of the model. Okay, remember, these are the performance of these are the terminologies used for the performance of the model. Okay, so this is how we do the classification, and you got the meaning of classification, you got the label data, you got the terminologies. And I hope with this it is clear. Then we'll go back to the programming platform to practice some more programs. Let's go for the third program. Okay, and let me introduce a new program. Okay, by reading data from a file instead of taking a toy data. Okay, so there is some error. What is saying? Name error. Uploaded name files is not defined. Okay. Could you see the screen?
Sir, no, sir. Screen is not
No,
visible.
sir.
Okay, very good response. Many are responding. That's great. That's great. Okay, there is an error. Now my target is next program to read a file and to carry out a thing, because here we just took a toy data and we learn to upload a file in Google Colab, and I'm struggling. Let me tell you why I'm struggling, because files is an inbuilt function that I have to put. So I will write a new code. These two sentences we have to write and run. Okay. After running, it will ask you choose files. So I'll go to my desired folder to choose a file, and I would like to choose the file like CSV file. Those CSV files are not but comma separated variables. Okay, .csv is known as comma separated variables, which are nothing but the Excel files. So after having this file, I can check here also. Here is my CSV file now. Okay. So after having the file, what I do, I will read the file. And for that reason, I have to write a sentence this. Okay. So iris.csv is a file. I'll show that file. What does it look like? But let's write the program first. Then I put data. I put the data into file. So I use data frame. And this will also not work because I'm using PD. Okay. So before that, I want to include many packages into my file. So what are they? See, pandas is a package. NumPy is a package to deal with the data. IO is a package to deal with the file. Matplotlib.pyplot is a package and subpackage altogether, which I define as PLT. These are the alias names. So instead of writing pandas dot a function name, I can write pd dot function name. So data frame is a function defined in the package pandas. Okay. So I can write pd dot data frame. This is my data. And I'll convert my data to NumPy, because this data is all is not convenient to handle them. They all are treated as text material, but we have numbers there as features. So NumPy I have to convert. You have to remember these two lines. After having the data frame, I am converting my data to a NumPy array. Okay. So ARR is my final data now for the timing. Now what I do? What I did, I'll tell you.
Hello.
Any doubts?
Sir, with your kind permission, this is Mustafa Shamim Firdaus. I'm a CA by profession, as well as I'm a community scholar and graduate of London School of Economics, by the way. With kind permission from you, sir, may I ask a question of mine, if you please allow me?
Please, sir, go ahead.
Sir, I'm very much proficient in R and MATLAB as well. I'm using Python for a long time.
Yeah.
But sir, I have a doubt, and it might be quite silly.
Yeah.
Sir, here we do write down, for the library, that import pandas as PD. Sir, why do we write down like this, sir? Yeah, panda is the library we are, importing. But
Yeah.
why, sir, this PD thing is writing down?
Yeah, very good. Actually, pandas is a very small name. So we are using a dot operator always. Okay. PD dot the function name data frame which is defined under pandas. Okay. So this is allies, allies. So
Okay.
Instead of writing pandas, you can write pandas here also. For the point.
Okay, sir. Thank you very much, sir. Thank you very much.
That's the thing actually.
Thank you
Am
very
I clear, sir?
much. Yes, sir. Yes, it is totally clear, sir. Thank you very much, sir. Thank you very much.
So the whole idea is that I'm doing something here, which I'll disclose later on. I'm just trying to know the features and the box plot. Okay. The box plot is sometimes essential. See, this is the box plot. Okay. So the box plot says that there are 4 features. Okay. And the upper end is saying the maximum value, the lower end is saying the lowest value, there is average value, and these are the percentiles. This value, the upper boundary of the rectangle is the middle value between the mean and the maximum, and so on. Okay. So what is box plot also you can search, and if someone is not aware, so box plot really gives the distribution of the features. Okay. Now let me tell you a few lines. So far, some lines of the program is not clear to all of you. Why I'm using delete? So I'm deleting the 5th row. I'm also deleting, 5th column. I'm also deleting the 0th column. Okay. Why? I'll tell you. Let me share the screen. See, how many columns are there? 1, 2, 3, 4, 5, 6. This is 0th column. This is 5th column. So the 5th column is the labels assigned for every iris flower. Iris is a rose flower, and there are many varieties there from this iris species. Okay, there are many varieties or many species from the flower family of iris. So we have the labels removed. We have the ID values removed. What we left with is feature 1, feature 2, feature 3, and feature 4. And if I want to compare the features, okay, I have to draw a box plot. That's what we did in using scikit, using the packages. Okay. And the reason behind showing this is that the reason behind showing all these things is you must know sometimes we require to manipulate the data set by removing some columns or some rows. That's the main reason behind this discussion. Okay. Every discussion has a purpose, and in this discussion we try to delete rows and columns. Okay. Next program is that, and in this case also you can separate the data file with data in all the 4. Please mute yourself. Someone has unmuted his mic. I would tell you that here is my data, ARR, where I have my data and labels all together. You can separate this file by using these kind of features given in NumPy, and you have your data and target separated this way. Okay, this way, data and targets, and you can run your program. Okay, so in the third program, what we learned is how to read a file in Colab and how to separate the data and targets. Clear? What could be our next program? Let's see. Sorry, it is unsaid. So in the next program, we'll do something called k-fold. Okay, and for that reason, I have to tell you something. So now I have to go back to my screen and tell you something about k-fold, and then we'll run the model. Okay, it's very, very important concept. Okay. Now we'll talk about k-fold. Okay. What is happening here is, if my data set is there, we may consider our 70% data for training and 30% data for testing. It may happen. Or in the very second example, I did 100% of my training and 100% testing. But generally, we do testing by using unseen data. Then we can claim that model is perfect. Even if the model doesn't have any idea about the data, even the model has not seen many data, still it can predict, then it's greatness. Okay. So this is one way, but this is not going to be believed by many researchers or the reviewers who can review research work. So what is the thing? K-fold. In k-fold, what is happening? That we divide the data into k-folds. For example, if 150, we have 30, 30, 30, 30, and 30. Okay. So we divide it. Let me change the color. I call it K1, K2, K3, K4, K5. Okay. So in the first run of my model, what I do, I will use K1 part, K2 part, K3 part, and K4 part to train the model, and K5 part to test the model. Okay. So in both the cases, I will use the data, I will use the label. Remember, this is data, this is label or target, we can say. So the data means these are the features, and for every row, we have a label. These are the features of my first data, and this is the label. I hope everyone get to know this. I mean, could follow this. In the second run, what I'll use, I may use all of them training and this for testing. Okay, so turn-wise, I will give every part an opportunity for testing. Okay, so every time we ensure that in all my 5 runs, we ensure that the data set has been given equal opportunity. There is no bias as such, because there may be bias. If I get to know that if I train my first 70% data, then I check 30% data, I may get accuracy 90%. By the moment I get this as 70% training and this 30% as testing, I may end up with an accuracy of 65%. Then which accuracy will be claimed by you as the final accuracy? It's a conflict. It's an unacceptable scenario. That's why k-fold cross-validation is always encouraged. Okay. So in the first run, I'll give this my model for training. I test this, I'll get the accuracy. I can name it accuracy score 1. In the second run, I'll train my model, test with a different test set, and I may call it accuracy 2. In the third run, I'll give 4 sets and K3. Other than K3, I'll give all 4 sets training, K3 testing, I'll get accuracy 3. In such a way, I'll have accuracy 5 accuracies. So we can claim the average accuracy of the model is accuracy 1 plus accuracy 2, all the accuracies added divided by 5. So this is one acceptable way to do the job. That's what will be our next program. Okay. And before I go to the next program, I will clarify another thing here. Okay. As I told you something called supervised learning. The supervised learning has come up with 2 flavors. Okay. So the flavor 1 is called classification problem, where you predict a discrete level, like any of the species of iris, or any target level called 1 or 0, or any level called high, moderate, low, or any level called sunny, cloudy. These are all discrete level. But there is another flavor called regression model, where we have to predict a continuous variable. Okay. So what do you mean by a continuous variable? A real value, in fact. So the real value, real scale is very much continuous, you know. I mean, if I say in between 10.1 to 10.3, I can have an infinite scale in between. Okay, it could be 10.0000001. It could be 10.000000013. Anything. Okay, that's why it's called continuous value. So regression problems are the values where the value to be predicted is a continuous value. For example, given many attributes, can you predict a continuous variable? CV I can write continuous variable such as temperature maybe. Given some parameters of the day, guess the temperature. Okay, or given so many parameters, guess the Nifty value, Nifty market index of the day, and so on. These are the classical example of regression. Okay, so but because of lack of time, I may not go up to regression. My target within this 90 minutes to get to know about, I mean to make you clear about the difference between classification and clustering. Okay, but this is also a problem you can explore, and there is a point to make here is that all the models that could do a job of classification can do the job of regression as well. So you can try by using the inbuilt functionalities and the models prescribed in scikit-learn. You need not do the code from scratch. You have to just simply use the syntax. Okay. Now let me share the screen and let's do another program. I'll be a bit fast because I would show you a bit example of clustering also. It will infuse a sense of confidence in you, so that knowing the basics, you can explore much more about these clustering and classification in Python. So as usual, I use the from keyword, from import keyword, and this time around I'm using decision tree classifier, not MLP classifier, another classifier. Okay, and I want to use the inbuilt data instead of reading it from my CSV file. So this is another way of reading. So there are many standard data sets already in, there in the Colab, and for that reason we have to have the syntax. I'll show you the syntax here. This is the syntax: iris load iris. So iris.data, iris.target. Okay, simple. Then next, if I want to have fold, three-fold, then I have to write n split 3, and that k-fold procedure, I can use some inbuilt function called stratified k-fold, which is imported from this package sklearn.model selection. Okay, you should not be confused. This is not a keyword. Sorry, this is a keyword taken from this package. Okay, so I'm using threefold. Now I will define one empty array or empty list, I call it empty list, just to save my just to save my accuracies from all my 3 run of the model. Fold is 3, so I'll execute my model thrice. Since I'll run my model thrice, I would like to use a loop. Hope I'm very much clear why the requirement of the loop. And there is a syntax for loop. If you are not aware of Python, you have to go through the syntax of for loop in the Python. And I'm using the folds here that I defined, dot split along with the data, so that you need not bother about the data and its corresponding label, because there is always a confusion that every time I keep on picking up the chunks from here and there, like K1 will be test, the rest will be training. K2 will be the testing, the rest will be the training. So you need not bother about the labels, the data and its corresponding labels, if you use the split function. Okay. Otherwise, you have to write the code from scratch, combining all those chunks of data. See, I'm writing only a code segment at a time, just to make it clear that you could follow me. Otherwise, I practiced these codes. I should have typed in toto in one go. I'm not doing that. Okay, just because you could follow each segment of the whole program one at a time. Now, this 4 decides the training data, okay, and the testing data. Okay, then you can ask a question: what is X, what is Y? X is the data for training. Y is the data, Y is the target for training. Okay, so X is meant for data, Y is meant for target. And X is the data for testing, and Y is the target for testing. Any confusion about these 4 lines? Someone has to say yes. If no confusion, you have to say no, no confusion. Please.
No, sir.
No.
No, sir.
No, sir.
Okay, very good. Now, Now we can train the model. In some discussion, I have done these 2 lines in one sentence, one statement, but here I'm doing 2. So there is a variation. Okay, we could have written like decision tree classified dot fit extend y thread, or you can do like this also, no issues. Okay, and I would say you that this in MLP case I did it in 1 line. I would show you, so you should not be confused. I'm talking about many variations. See, in this case I have done in the 1 line. Okay, next we have to print the CLF score, or we can say append. Remember, append means in the very first instance, I have a training and testing data and target fixed. Training, I mean, the model is trained. Now the score is calculated, and this score is appended to my empty array. Okay. So in the first run, it will get 1 value. In the second run, it will get value accuracy 2. In the third run, it will get accuracy 3. Finally, I have to find the average of this. Okay. And you remember, all these lines are in the loop. And in Python, whenever everything is in indent, same indent, so they meant for the loop body. Okay, this is the loop body. Then I'll come out of the loop. I'll calculate the average score. Average score is sum. Sum is an inbuilt function. Length is one inbuilt function. So 3 values divided by 3. Sum of 3 values divided by 3 giving me average score. And the average score is like this. Okay. And before that also, I would like to see every value that we can also print the individual scores from every run of the model. Okay, see, these are the data, target, everything there. So the array of individual scores, see, in the 3 runs, I have 3 accuracy scores. See, different accuracy scores. Sometimes I got 98%. Once, I mean, on the second time, and second occasion, I got 94. On the third occasion, I got 100% score, and the average is 97% accuracy. Okay, so it is a general, culture. I mean, we should not say like it's a trend. We can say it's a trend whenever you report that the efficiency of the model, the performance of the model, people use generally 10K4. Okay, K equal to 10. So the 10-fold run means the model will be run 10 times, and the average accuracy, whatever it is the final performance of the model. People do that way. Okay, I hope after this it is very much clear. Okay, and then having knowing these basics of classification models, the K-fold cross validation, training data set, testing data set, and the difference between regression and classification models, and labeled data, non-labeled data. Now we switch to call something about clustering, which is unsupervised learning, and that is dealt with unlabeled data. Any doubts so far? Please ask questions. Alex, should I continue or?
Sir, 5 minutes you can continue, sir. 5 to 10.
5 minutes now. Okay. Okay. So we talk about clustering, which is also known as unsupervised learning. So whenever there is no label, we have only data, no label here, no label, only data, okay, and there are attributes, then we can make clusters. Okay, so if there are 1 to 30, okay, so there may be 8 data points belonging to this cluster, there may be 8 data, there may be 14 data here, and so on. Okay, so how it is different from classification? In classification, we draw a decision boundary so that mangoes will be this side, oranges will be this side. In clustering, we do not know what is mango, what is orange. Clear? Because there is no label. We have no information that this is mango. We have no information that this is orange. We have no information that this is mango. So there is no label as such. So we have to group them. Clustering means grouping actually. So how to group them? By taking these features and finding the Euclidean distance. So how this data point is close to this data point. If you do such an algorithm, assigning that there are some data points which are very close to each other, they can be put into one cluster and so on. So I was planning to talk about 2 clustering techniques. One is k-means clustering and one is hierarchical clustering. Okay, so in k-means clustering, what is happening? In k-means clustering, okay, suppose these are the attributes. In k-means clustering, we have to define the k first. So we have 2 clusters. Okay, so we have to find the distance between them, Euclidean distance, and sometimes, Hamming code distance if the data are only 0, 1s. Okay, and sometimes, there are many Minsky distance. Okay, there are many popular distance or similarity score calculations. Okay, you
Hello,
can.
sir.
Sorry. Any question?
Sir, your screen is not visible.
Oh, you should have told me. Charlie on Baba. I've told many things already. See, I've told so many things. See. So there is mango and there is orange. This is the classification. We have to draw the decision boundary. Whatever the algorithm we are writing, the algorithm is indirectly drawing the decision boundary so that all the mangoes are here, all the oranges are here. If some mangoes are here, then that contributes to the, weakness of my model. If some oranges are falling in this part, then they contribute the weakness of my model. So majority of mangoes here, majority of oranges here, that's where my accuracy is. But in clustering, we have to put the data. Okay, so by putting, how could we put data? By finding the Euclidean distance between these 2, or finding the Minsky distance, or finding the Hamming code distance, or any such available similarity score between 2 data points. Okay, and for that reason, we will be using k-means and hierarchical clustering, and k-means means we have to define k equal to 2, then we have to pick the data points and put into these clusters. Okay, but in hierarchical clustering, what will happen? If we have 5 data points, we can find that these are similar, then we can find that these are similar, then we can find that these are similar, then we can find these are similar. Okay, we have to draw a tree like this, which is called dendrogram. Then we have to cut the dendrogram at some height. If I cut the dendrogram in this height, then I have 3 clusters I'm getting. Okay, so the benefit here is that the number of clusters is not defined. So naturally, it is a kind of automated clustering. The number of clusters we are not defining, it is naturally coming up. But the number of cluster depends upon in which height you are cutting it down. So these are the two difference, and I think I have no more time left with me, but I will share the codes with Alok sir. You can get from him the clustering codes as well. You can practice, and at any point of time, if you have any doubts, you can contact me on this mail ID. Okay, or on this number in WhatsApp, or you can have a call to me. Okay, so I work, my work is like medical imaging I'm interested on, and I'm more interested on computational biology. So if these are the areas of interest for you, also you can we can discuss these things. Okay, and of course any machine learning stuff you have doubt, you are free to call or free to contact. If I am free, I'll reply instantly. Otherwise, I'll seek some other time to discuss the things. With this, I end my session here, but you are free to ask any queries if you have.
Thank you, sir. Now the audience have few questions, sir. So one by one, they will ask you question.
Yeah.
So I have got some name. Pranav Gogoi want to ask question.
Please ask the question.
Or if he is not ready, then other student can ask.
Hello, sir.
Yeah.
Sir,
Yes, Kumar.
sir, if I have to calculate the specificity, I have to find out the confusion matrix or not?
Yes. Yes, you have to.
Oh, yes. So that was my confusion, sir.
No,
Means
for
I find out
any
the confusion
matrix, for
first.
any, let me clear you something, that I have shown you only one confusion matrix, and specificity is true negative divided by true negative plus false positive. Okay, and this true negative concept or false positive concept we can take from confusion matrix only. Okay, point one. Point two, that sir, whether I mean we have two classes here, positive and negative. That's why we are saying me true positive, false negative, true negative. What if we have multiple classes? Even if multiple classes, you can have all these calculations possible: precision, recall, specificity, and everything. Okay. And you can explore in the network how to calculate specificity or precision in a confusion matrix of size 3 or size 4 and so on. Okay, or you can discuss in some later point of time. But to be specific, to answer your query, yes, we need confusion matrix to calculate specificity.
Okay, sir.
Next question. Yes, Amnesha, go on.
Sir, you have just explained the difference between classification and clustering. Sir, I didn't understand what is the process of clustering actually.
Okay. See, in clustering, we have the data set. So what are there in the data set? Only attributes, no labels. Okay. Suppose this data set has 3 attributes. So what we do is we calculate these attributes similarity. Okay. So for example, if it is k-means algorithm, we calculate the clusters. There are two clusters if k equal to 2. Initially, the center of the cluster is 0, 0, 0. 0, 0, 0. You can ask me why it is 0, 0, 0, because there are 3 attributes. Now, what I'll do, I'll calculate the distance between this, the distance between this, the distance between this, the distance between this, and so on. So initially, what I do is, instead of putting 0, 0, 0, what I'll do, I'll randomly assign something there. Suppose I have 5 data, so 3 data, 2 data. I would put 3 data here, and I'll put 2 data here. Now the average of 3 data gives me the center. It may be 2.5, comma 2, comma 1. It may be 3, 4, 2.2. What is this? The average of these 2 values. What is this? The average of 3 values. Someone is asking some question. Please don't disturb now for the timing. So after having this average, I will calculate for all 5. Okay. Then whatever the minimum, they will find a position here. Okay, I'll calculate the distance between them also. I mean, with that also. Okay. So the idea is, now we reorganize this. Sometimes some point is coming here, some point is coming there, some point is coming here, some point is coming there. So this process is going on. They just keep on changing their position from this cluster to this cluster, this cluster, this cluster. So after so many iterations, we'll find out the mean, the center of this is not changing much. So we'll stop there. And finally, we'll get to know that which points belong to this and which point belongs to this. This is the basic meaning of cluster. And classification means what? We have many algorithms. I am not having enough time to talk about a particular algorithm, but I can say that whatever the algorithm, they find a decision boundary. Okay. Now they try to put some data. Suppose mango and orange are my labels. They try to put mango this side. They try to put orange this side. If there are 10 mangoes, 10 oranges. And they could put 6 mangoes this side and 7 oranges that side. Okay, and 3 oranges this side, 4 mangoes this side. So these are my errors. So my accuracy is 13/20. Because I could correctly put 6 mangoes this side of the decision boundary, I can correctly put 7 oranges this side of the boundary. So I have 13 occurrences of correct choices. So it's 13/20 the accuracy. This is the difference between cluster and classification. I hope it is clear to the participant you raised the question.
Yes, sir.
Any question? Next.
Hello, sir. My name is Dipanjan. Sir, I just wanted to know that is clustering and regression are related to each other or not?
No. Because in regression also we have the label. In regression also we have the label, which is a continuous variable. Okay. So certainly regression and classification falls into the same category of supervised learning. Okay. So the answer is that regression cannot be equal, anyway similar to clustering. Can never be. Okay.
Next. Any question? Yes, Janti, you can ask.
Sir, what is the meaning of actually reinforcement?
Okay. Reinforcement means, see, reinforcement is a different flavor altogether. Okay. though the supervised and unsupervised seems to be a bit similar, in reinforcement what is happening? Suppose I have a robot. Okay, now the robot has to go to the balcony to pick up one basin of water. Okay, this is the balcony. So this robot comes to this room. This room has an opening. Okay, then there is a room like this, and this room has an opening. Okay, this room is also an opening. Openings are the parallel lines. Okay, now, and after this there is a room like this, and this room is also having opening, and this room has no opening. Now the idea is, if the agent has to go to the balcony, he has multiple ways to explore. He can go to this way, this way, this way, and to the balcony. Okay, but if at any point of time he comes to this way, he will reach this room, and this room is locked. There is no opening out of that, so it cannot go. Okay, so whenever it can go this way, every room it passes, it will be rewarded with some point. Every room it is getting blocked, it is punished with some point. So once it is punished, it will go back to the previous position. Okay, so the reinforcement is correcting itself. So the agent is a program or a robot which is exploring so many options to go to the balcony. The purpose is balcony, but there are many ways to reach the balcony. Okay, if at any point of time it cannot, it is a blockage here, so it has to backtrack. So whenever it is backtrack, it will be punished. Whenever it is keep on moving, it is collecting point and points. So at every junction we have assigned points. So reinforcement learning is that whenever we send the robot or the agent from source to destination, it must reach the balcony smoothly. It should not be an infinite loop or a loop which is never ended. Or something which is not delivering the result. Sometimes we do not get results in algorithms. Sometimes it never stops. Okay, so in such situations, we should have reinforcement algorithm where we have one environment which is nothing but the search space. We have an agent which could be a program or a robot, and the robot explores the environment to reach the desired goal. Am I clear?
Any more
Yes,
question? Anyone want to ask?
Sir,
Yes, go on, Purnima.
sir, what is confusion matrix? Can you please explain again?
Yes. See, my model is expecting the targets cat, hen, and cat. Okay, and here is my model. My model predicted, I'm testing 4 data. Okay, I'm testing 4 data, and this 4 data has these 4 labels, and my model predicts the labels like C, 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 and C. Clear? So I'll draw a confusion matrix. And here I can write cat and hen, cat and hen. Initially, the values of all the grids are 0. Initially, all of them are 0. Whenever I find a success, I will increment. So, I'm expecting a cat, I'm getting a cat. So it becomes a success. Cat, cat. Expected value, target value. Okay. Now, I'm expecting a hen, getting a cat. I'm expecting a hen, getting a cat. This will be incremented by 1. I'm expecting a hen, getting a cat. Again 1. I'm expecting a cat, I'm getting a cat. This is also 1. Okay. For example, I'm expecting a hen, I'm getting a hen. So this will be incremented. So the total is 5. So out of by 5 instances, how many number of times I'm getting correct? In this instance, I'm correct. Here I failed. Here I failed. Here I'm correct. Here I'm correct. So 3 instances are correct. And these are my 3 instances correct. So my accuracy is 3 by 5. Clear? Because I'm expecting a cat, I'm getting a cat. I'm expecting a hen, I'm getting a hen. So these 2 values combinedly giving me the correct choice, correct guesses. So out of 5 instances, my model correctly predicted 3 times, failed 2 times. Here is the failure. Here are the failures. Okay. So all these values can be put together to determine different kind of, metrics. I mean, this metrics means evaluating measurements. One of the metrics is accuracy. It could be precision. It could be recall. They have different significance, different meaning, and you can explore this. Okay, any doubt?
No, sir. Thank you.
So if more question you can ask, or we can conclude here. So, sir, I think there are no more questions. We can see good response from them. So I hope this lecture will be benefited to them. So if they have listened well. Thank you so much, sir.
And if they have not listened it, or they have left sometimes and joined in between, they will not appreciate and finally say that, okay, this teacher has not taught well.
So we are providing this video lecture to them.
Okay.
Hope they will listen again from the YouTube. Thank you, sir. Thank you so much.
Thank you.
पात्र सर जयंत हियर।
जयंत जी कैसे हैं? ठीक ना?
ठीक, बहुत बढ़िया। आप कैसे हैं?
बस दुख सुख चल रहा है।
Okay, it was a
दिन के बाद मिला, miss you. Sometimes we miss you.
Miss you too. It was a splendid session. I have got all of your words very carefully.
Thank you, sir. Thank you.
Thank you so much.
And convey my regards to Sanivar, sir. Jayant, sir,
Sure.
Allow convey my regards to Sanivar.
Yes, sir. Sure.
Yeah, presently he's busy with some
meeting.
Okay. Okay. Nice to meet you all again. We'll meet soon. I mean, plan to visit Agartala sooner, just to give surprise to Jayanta sir and Shanivar Bhaiya, and of course, hello. Okay, I'll give surprise.
Thank you so much, sir.
Thank you. So, should I disconnect now?
Okay, sir.
Of course, sure.
Yeah. Thank you so much, participants. Thank you. Wish you all the best.
Thank you, sir.
Thank you, sir.
Sir.
Thank you, sir.
Thank you, sir.